Hey guys, I hope you're doing great today. Well, today is an important lab in which we are going to configure a remote backup for our Terraform state file. Guys, in the last lecture, if you have watched it, we discussed about what is a Terraform state file and what is a Terraform state file backup. Okay, there were two files when we saw that when we applied Terraform apply, we had two files, terraform.tfstate, which contains every information about our current running infrastructure, and we have a previous version of that terraform.tfstate file, which is terraform.tfstate.backup file. So we saw that those files were updated when we made some changes in our infrastructure. So when we run terraform init command, you saw that there was a message printed or shown by Terraform that Terraform is initializing a local backend. Okay, now that local backend is actually the backend of our VM where our terraform.tfstate file is located. So after that, we also discussed about the two types of backends. Local backend, if we are having our terraform.tfstate file locally on our VM, then this is actually our Terraform local backend. But if we are having terraform.tfstate file on any of the cloud providers in storage bucket like S3 or in a blob container on Azure or in GCP storage, then this is actually our remote backend. And also, we discussed why do we need a remote backup? Because in local backend, when I am the only person who is managing the infrastructure, then I can have a single terraform.tfstate file locally on my virtual machine. But what if we are a team of 10 or 20 DevOps engineers and they are working on the same infrastructure? So definitely we should have our terraform.tfstate file on a remote location so it is accessible or everyone can manage or see what infrastructure we are having. And that is actually the purpose of configuring a remote backup to store our terraform.tfstate file on a remote location which can be accessed by our DevOps team members at any time. And it is really easy to configure a remote backend. But if you have not watched my previous lecture, it is really important if you understand what is the purpose of Terraform state file and terraform.tfstate.backend file, then this would be more easy for you to understand real quick why do we need to configure a remote backend. And I have, by the way, shared everything on our Terraform by DevOps Molvi repository, which contains every lab and configuration file we have done so far. So make sure that you should take a fork and you must have it so that you can practically perform what we are doing here in our lab sessions. So you can see we have Azure. I have opened it here, and this was actually our first lab in which our infrastructure was provisioned on Azure, right? And also I have told you guys how we can install Azure CLI on a Linux Ubuntu machine. After that, we logged in using our Azure CLI running az login command, and we created a free subscription. And also every detail is, by the way, mentioned in this file. Now today we are going to configure remote backend where we are going to store our terraform.tfstate file on Azure Storage in a blob container. So I have created two separate files in this folder, remote backend configuration, which is here. All right. So I have opened everything in separate tabs to make it more convenient for you, so that you can easily know where are we headed. And now there are actually two files, Terraform configuration files here, main.tf and storage.tf, and we are going to work on both files. The main.tf file is actually the same file that we had in our first lecture, and it contains the resources that we provisioned on our first lab, in which we had 6 resources, including a resource group, a virtual network, and a private subnet, a public IP address, and a virtual machine on our Azure platform. Now, when we are doing that lab, we were having our terraform.tfstate file on our local VM. I can show you here. You can see now we had terraform.tfstate and backup files on our local VM. But what now, the important thing is that I want to have this terraform.tfstate file, which is the core of our infrastructure, on a remote location on my Azure Cloud, or it can be your AWS S3 bucket, or it can be a GCP Google Cloud Platform bucket. But today we are going to perform this lab with Azure, and it is your choice if you want to use AWS S3 bucket, which I will try my best to cover in the future lecture. But today the main purpose is to understand what is the purpose of a remote backend and how we can configure a remote backend using Azure. So there are actually two Terraform files, main.tf and storage.tf. So you don't have to confuse that. What is the purpose of storage.tf and main.tf? The main.tf file is the same file we had in our first lecture, in which we provision a virtual machine with its prerequisites, okay, network, etc., firewall. Now we have to modify it more for our remote backend configuration. Now I don't want terraform.tfstate file to be created on my VM. Instead, it should be on my Azure Cloud. So now we need to study about the configuration, additional configuration that we have to do in our main.tf file. So there are actually two Terraform configuration files, main.tf, and this is the second file, and I will tell you why I created this storage.tf file. The purpose of this file is to create a new storage account and a new storage container on Azure, so that we can see what changes are occurring when we run terraform init and terraform apply command with the terraform.tfstate file. So you will definitely get what's the purpose of both files. So first of all, we need to discuss about the Terraform main.tf configuration file. So you can see this is our main.tf file, and if I have a quick review, hold on, I will zoom it, and now you can see we are having our provider as azurerm, the subscription client ID, client secret, and tenant ID. We have discussed in our first lab, and we are creating a resource group, a virtual network. These are actually the prerequisites. These resources are required by the VM, and a public IP address which was attached with our VM using this network interface card, and this is how we have configured our IP address. And after that, we created a virtual machine. only one resource, only one virtual machine using this main.tf file, and I was having everything in a single main.tf configuration file. Now you can see we created this DevOps Molvi Linux VM. So I would strongly recommend that you must run this configuration file on your VM so that you can see how we can provision infrastructure on Azure using Terraform. Now guys, today we are starting from this point, okay, and I have updated the same main.tf file and modified it for the remote backend configuration. You can see we have Terraform Remote Backend configuration, and there are actually 4 more steps that we should perform so that we can easily configure our remote backend for our terraform.tfstate file. So we need a resource group. Okay, now a new resource group would be created with this name, backend underscore rg, means resource group, and I have named it as DevOps Molvi backend rg. This is my resource group, and the same location that we had while we created our virtual machine, and it is East Asia. This is the location and where our storage account will be created, where our blob container will be created. So this is actually the location, and you can have East US or the location of your choice. Now we are creating a storage account for our terraform.tfstate file. Terraform.tfstate file is a JSON file. I hope that you haven't forgot every concept that we had already covered so far. So terraform.tfstate file is actually a JSON format file. Okay, so we have our infrastructure information in a JSON format in our terraform.tfstate file. So this is actually the storage account, SA storage account for our terraform.tfstate file. So we must have a storage account, and its name is DevOps Molvi Storage. I have given this name, and remember that it should be globally unique. Okay, just like if we have a storage bucket on Google Cloud platform or storage bucket on S3, their names must be globally unique. So I have this DevOps Molvi Storage, and this is actually the resource group name, backend underscore rg, and it will take the name from here, and this would be our DevOps Molvi backend rg, our resource group name, and this is my location, which is East Asia. Okay, these are variables, and we are getting their values from here. And now account tier, just like we have the account storage account types. Okay, storage types, which is standard, and LRS stands for locally redundant storage, LRS, which is the storage type in Azure. So this is my account replication type, locally redundant storage. Now a blob container in Azure is just like a bucket. Okay, a bucket where we have to actually store our terraform.tfstate file. So it is actually a blob container. If you have worked on Azure, you must know that. So a blob container will have a terraform.tfstate file, and this is actually the container name and the name of the file. Okay, this is the name of the blob container, tfstate, or I can have it DevOps Molvi tfstate. So this is actually the name. You can have the names of your choice. Okay, so don't worry about the naming conventions. And this is my account storage name. So account storage name, you can have it from here. This is actually the DevOps Molvi Storage, which is my storage account name, and it is actually private. You can have it publicly available, but now For security reasons, I will set it to private, since our terraform.tfstate file contains every information about our infrastructure. It can have our, so it must be private. Now here, actually, in the last step, we are configuring a remote backend. Since we have everything ready, we have all the prerequisites, we have a resource group, we have a storage account, we have a blob container. Three things: storage account, a resource group, a storage account, a blob container. And that blob container will have a terraform.tfstate file. So now we have created a resource group, we have created a storage account, and now we will have our blob container, which will contain our terraform.tfstate file. And this is the resource group name. This is my DevOps Molvi storage as storage account name. Container name, just like we had while we were creating blob container, tfstate. And this is actually the key file. All right. So when we will run terraform init, terraform plan, and terraform apply commands, it must create a resource group. This would be, it will create a resource group DevOps Molvi backend RG, and then it must create a DevOps Molvi storage account. And after that, it should create a container named tfstate, and that container must have a terraform.tfstate file. So that's how our backend configuration will be complete. So let's try it out. And I have this main.tf file, and if I edit it main.tf, and I have all the configuration just like we have in our GitHub repository. So you don't have to worry about just take the clone or just copy the content of the file, and you can run it on your local VM, a Linux VM. So everything is ready. We just have to run Terraform commands so that we can have a storage account, and our backend configuration must be completed for our terraform.tfstate file. Just to show you that we don't have any storage account on my this Azure account. Okay, so we are going to have it created from scratch. I don't have any storage account in the storage browser on Azure. So you can see that I have this terraform.tfstate file on my local machine. This is my local VM, and I have this terraform.tfstate file. So it means that it is my local backend. But now we are going to shift our local backend to the remote backend. So we will have our terraform.tfstate on our Azure Cloud in a storage. There would be a storage resource that we create and a blob container which will contain our tfstate file. So first of all, what I will do is that you can copy the code from here. I'm sorry, I have everything in the same main.tf file. I will copy this code, and I'm not adding this block. I will add it at the end. Due to some issues, I will add this block at the end after creating the other required resources. So I will add it main.tf, and I will add shift insert. And now what we are doing, we are adding a resource group for the backend storage account, a Terraform storage account for tfstate, and a blob container. So for now, I will run Terraform init, and you can see we still have the local backend. This is initializing the backend, means that it is initializing the local backend. Now I will run Terraform plan, now you can see that it is going to add 9 resources. So if you can count all these resources, we had 6 resources from our VM, and therefore these 3 additional resources will be added to our Terraform plan. And now I will run Terraform apply so that we have a resource group created for our storage, a storage account, and a blob container. And after that, I will add the code where we will have actually the backend configuration. Now I will enter yes, and it will add these 9 resources. So I destroyed everything, and now I am recreating the infrastructure again. So you can see it is creating the virtual machine. Now we are having our storage account created, and now our storage account will be created, and after that we will create a blob container. So it will take a couple of moments, and Terraform apply takes time because it is actually provisioning infrastructure on the cloud. So we have to be patient, and now you can see apply has been completed and 9 resources have been added. So still we have our backend on our this machine, okay, on my local machine. So now I will add this code. Actually, this code block is the main configuration for our remote backend. So you can see that we have created the resource group, we have created the storage account, we have created the blob container. Now it will contain our terraform.tfstate file, right? So I will add this code in my main.tf file, and again we will run shift insert. So now I will initialize my Terraform, okay, clear. I will initialize to see whether our backend is going to be shifted from local to the remote, and initializing the backend. Now this was actually the main point that I wanted to show you. It is saying that, do you want to copy existing state to the new backend? Of course we want. We are shifting our local backend to our Azure Cloud, and pre-existing state was found because we have a terraform.tfstate file on our virtual machine, and while migrating the previous local backend to the newly configured azurerm backend. Okay, now this is the actually our remote backend, which is azurerm backend. No existing state was found in the newly configured azurerm backend. So no existing state was found in the newly configured azurerm backend. Do you want to copy this state to the new azurerm backend? Enter yes to copy and no to start with an empty state. So I will enter yes, and then we will be able to see our terraform.tfstate file emptied on our local VM on this virtual machine, and we will have our terraform.tfstate file migrated to Azure. Now I will enter yes, and you can see successfully configured the backend azurerm. Guys, that was actually the thing that we wanted. We have actually successfully configured our backend azurerm. Terraform will automatically use this backend unless the backend configuration changes. Now our terraform.tfstate file, every time if we provision new resources, that file will be actually updated, and we will have our terraform.tfstate file on our Azure. I will actually show you, but after we have it, a Terraform plan, we will run Terraform plan to see what output we have, since most of the resources have already been provisioned, and now it is refreshing state. So it is saying that no changes, your infrastructure matches the configuration. And now I will run Terraform apply to see if anything new is happening. Since we have everything, we just change the remote backend. We change from locally to remotely, and it is saying that no changes, your infrastructure matches the configuration. Terraform has compared your real infrastructure against configuration and found no differences, so no changes are needed. Apply, complete, and now we will be able to see whether we have our terraform.tfstate file created on Azure. So I will go to the resources. By the way, you can see DevOps Molvi backend resource group. It has already been created. Now it should have a storage account. We can see DevOps Molvi storage as per our main.tf file. If I open my main.tf file, and if you can see, this is actually our storage account name, and we have it. Now you can see we have this storage browser, and it should have a blob container. Now there is a blob container tf state. Okay, this is actually the tf state, and this is the container name. Okay, I have this for my terraform.tfstate file, I have this container name, and in this container we are having our terraform.tfstate file. And if I want to download it, we can download it. You can see I have this terraform.tfstate file, and if I want to edit it, now you can see we will have everything on our Azure backend, and this is our remote backend. And now I can share this terraform.tfstate file with my team members as well. So it contains our virtual network and storage account, etc. So guys, that's how we can configure our remote backend. Now for your further learning, I have created this storage account. Okay, and this is just to get your hands on Terraform. You can add more resources and check the state file in Azure for the changes every time we create new resources. After all, we are going to put in more resources on Terraform. That's why we have to compare if that terraform.tfstate file is getting updated each time. So I can simply copy this file. So there is not much huge going on. I'm just creating another storage account, SA2 DevOps Data 2, and I'm creating another blob container. So let's try it out and see what we get. I will create nano storage.tf, storage.tf, and I will just paste this file, and now I will initialize Terraform init. Backend has been initialized. Now it means that this is our azurerm backend. So I will run Terraform plan, and we'll see what we have additional resources, and then we will compare our terraform.tfstate file on Azure. So you can see we are adding 3 more resources: a resource group, storage account, and a blob container. And I will run Terraform apply, and it should not take much time because we are only provisioning 3 new resources. So every time it refreshes the state, that is why, oh sorry, apply has been cancelled. I will run again. I will enter yes and see if we get another blob container. Now it is creating a new blob container, and it will not take that much time. And another storage account is also being created. You can see we have to be patient while running Terraform apply, since I told you that it takes some time. And now storage account 2 is being created, and a blob container will be created as well. So 3 are being added. So it means 1 new resource group, 1 new storage account, and 1 new blob container. So it has been completed. Apply complete. 3 resources have been added. So guys, now you can see we have a new resource group. Okay, this is my new resource group as per my storage.tf. Let me open it, storage.tf, and we have this DevOps Molvi resource group, new resource. We have this DevOps data 2, and you can also see from your dashboard that DevOps data 2, that storage account has also been created. I will just open it in a new tab. But the most important thing that we must see is to see the changes in our terraform.tfstate file. And I will go to the DevOps Molvi storage, and I will open the storage browser, and I have this terraform.tfstate file. So I will just download it. So I have opened it, and now if I want to search for this container, new storage account, and this blob container to see whether we have it or not. And you can see we have this new blob container. Similarly, if I want to search for the new storage account, we should have it in our terraform.tfstate file. So guys, that was actually an amazing thing. I was super excited to share that how terraform.tfstate works remotely. We have everything updated on our Azure storage account. So that's it, guys. That was actually our practical session in which we actually configured our remote Azure backend. So you can find the remote backend configuration on this repository. I have already shared this repository URL. I will add this repository link into the description. If you just want to configure the remote backend, you can try it out. You just have to update your main.tf file accordingly, or you can just copy paste on your machine and you can run Terraform commands. But the main thing that you must understand it is how it is done. So I have already put the comments and I have described what's going on each resource. So the storage.tf file is just as additional file. So you can configure more resources and check your terraform.tfstate file whether it is having new additional changes. So we actually practically saw everything in this lab. So make sure that you must try, you must work on it, and you must provision, and you must have a new remote backend instead of a local backend. So that is actually a really important lab that you must do it on your machines. I would strongly recommend that. I will see you in the next video. Make sure to subscribe DevOps Molvi on YouTube. We are going to hit 1K. So have a good one. Take care and bye.